Good night. This is truly Professor Dr. Dolphy Gilpin in continuation here with chemistry. We have concluded with our alphabet chemistry and take a little deviation from the word chemistry into some calculation of molarity, concentration, molecular weights and concentration, density, and so on. And so without further delay, I will get right into the molarity problem and solutions. So let's begin with a little history. These chemical problems with molarity and molality and concentration and molecular weights first began at the high school level, and in 1973 it was a beloved chemistry teacher, Sidney Fenton, from the GCE Cambridge era. At that time, the British were governing the education system of the whole Caribbean, and Cambridge O-level and A-level was the order of the day for high school and advanced high school. So in 1973, when I peaked, and as I've told you that although I peaked and was ready for my chemistry and maths and other subjects to pass, it was sort of wasted, and I was to wait until 1974 before I could take subject that I had already peaked into. Nevertheless, I took them in 1974 and got distinction, but I could have just as well got distinction had I put some effort in it in 1973. And so I was delayed 1 year backwards. And this was significant to me because it affected me right throughout my educational career, right into my college and university. When you're supposed to be at a certain place at a certain time and you're delayed by 1 year, 1 year is a lot of time. I was delayed by more than 1 year due to some other thing at the elementary level. But nonetheless, such is life. So here we are in molarity, and I give credit to that high school chemistry teacher, Sidney Fenton, who later went on to become the principal of the high school Excelsior, Kingston, Jamaica. He later went on to be, and I mention his name because he came at my residential practice in 2000 and residential research practice, somewhere 2008, 9 or 7, 2007, 8, 9, and he visited me there. He was my favorite chemistry teacher. I saw that I completed my advanced level with him, but that was due to another setback. And a setback that happened. So I mentioned his name because not only did he talk well, but he also came to visit me at my residential practice after returning from the States to the island of Jamaica. So honor and credit to Sidney Fenton. We're calculating some molarity and molality, and whenever I see these things at that level, his name comes up and his memory. So I don't have enough paper, so I'm going to just do the problem by audio and then write out the significant numbers and then solve the problem. A solution is prepared using 15 grams of sodium sulfate. So what we have here is 15 grams of sodium sulfate. I'm going to ready my pen, and this is Na2SO4, sodium sulfate, 15 grams. And the volume of the solution is 125 milliliters. And so we have a volume of 125 milliliters. And it said here to calculate the molarity of the given solution. And so we want, if we let M be the molarity, okay, this thing is getting very dull, so let me discard it with it, and see if I could come up with a brighter one. So M is equal to molarity. Calculate the molarity of the given solution of sodium sulfate. Molarity of So that's a problem. We're going to calculate the molarity given 15 grams of sodium sulfate and volume. All right, so now we calculate the molecular weight or molecular mass of sodium sulfate. My goodness, why all these pens are the ink. Let's see if we could find another thing. Excuse me for all these only a red pen is available here, and so I'm going to have to use the red pen. Only a red pen is tangible, and everything else is intangible, or the ink is finished. So here we are. M equals molecular weight of sodium sulfate. And so we calculate the molecular weight of sodium sulfate. M equals now to 23. 23 is the molecular weight of sodium sulfate. If we have sodium here, Na, and we have it as 11, 23. So this 23 is that. And so we have to multiply it by 2 because we have 2 atoms of sodium. And so sulfur atomic number is 16, is 32. 16 is the atomic number, 32 is the atomic mass. So we have plus now 32, and we have 4 atoms of oxygen, but one atom is 15.99, and we're going to use 16 for easy calculation here. So it's plus now 16 multiplied by 4. And we get that now to be equal to 142. So that's the molecular weight of sodium sulfate. So now the number of moles of sodium sulfate, the number of moles of sodium sulfate is, if that's equal to N, then N would be equal to the mass in gram over the molecular weight. So that would be equal now to the mass in gram given up here was 15 grams. We're keeping every unit the same, grams, and grams go with liter. 142 as the molecular weight. And that will be equal now to 0.106. Now the volume of sodium sulfate is given as 125 milliliter. The volume of Na2SO4 was given as 125. So we have to calculate now the milliliters to liters. So liters will be equal now to, in liters, that will be equal to 125 upon 1,000. And that will be equal to 0.125. And I think that's in a fraction that will be equal to 1/8. But we'll keep that as a decimal. And so the molarity of the solution, which is what you want to find, the molarity is given as now the number of moles over the volume of the solution. And so that will be equal now to 0.106, which is here, and that will be over now 0.125. And then when we do that calculation, we get 0.85. So that is the molarity of the solution. That's what we wanted was to find there. 0.85 is the molarity of sodium sulfate. All right, we're going to take a break here because our introduction was a bit long, and then we'll return to do some more molarity. But notice that this molarity went from high school to college to university, and the only difference is that whereas we were limited to certain elements in high school and junior college, at university, then we began to do the whole spectrum of elements. And in 1973, there were about 105 elements discovered. In 1974, there was about 106 elements discovered. And in 1975, there were still 106 elements discovered. Today, we have 118 elements discovered. So at university level, we do the molarity with all the various elements discovered, whereas in high school, we just limit ourselves to the first 20 and plus some other specialized element like iron and manganese and copper and gold and silver and, you know, some very popular elements. First 20 and that. In junior college, we had the first 40 and plus some other specialized. And then in university level, we had all the spectrum of elements from 1 to 118 in atomic number. So that's the calculation of the molarity there, of the solution. We'll take a break and then we'll return to some more calculation of molarity.